Hi everyone, Jonathan here. In this video, I'm going to give you my take on section 2.1, which is about the tangent problem. So the book doesn't really actually define the tangent line to a curve. It says the word tangent is derived from the Latin word tangent, which means touching, which is true, but it's certainly not a definition. And it also says for a circle that the tangent line is a line which intersects the curve once and only once. So another way of thinking about it is it intersects but doesn't cross. But even that definition isn't very accurate. To define precisely a tangent line to a curve, it turns out that for any smooth curve, if you look at the curve up close enough, it's going to look like a line. And the line that it looks like is the tangent line. So to illustrate that point, we can take this point here on the curve, and I can zoom in on this curve, and I zoom in more and more, and you can see we're getting closer and closer. And at this point, you can still see that it's curving. It's not straight. But as I zoom in more and more and more and more and more and more, at this point, the curve itself, I'm so zoomed in that you can't even tell the curve isn't a line. So this curve is now appearing to be a line, and if you extend that line out to infinity, that is now the tangent line to the curve. Now using this definition, we can see that it's entirely possible for a tangent line to cross the curve. In fact, it can cross the curve at the point where you're forming the tangent line. So what we're looking at now is the graph of y equals x cubed. And if I look at the tangent line at x equals 0, and zoom in and in and in and in and in, eventually we're going to get to the point where the curve is indistinguishable from the x-axis. So that means that the x-axis is the tangent line to the curve at x equals 0. And if we zoom out again, of course, we can now see that the tangent line does in fact cross. At 0, the tangent line at 0 is crossing the curve. So that's definitely something which can happen. The other thing the book does in this section is it shows you that you can approximate the tangent line to a curve with secant lines. A secant line is simply a line that goes through 2 points on a curve. So what we have here is the curve y equals the quantity of x squared minus 1 times the quantity of x plus 2. So this blue line is a secant line to that curve because it's going through 2 points on the curve. Now, you probably remember from previous math courses that to define a line, you need to know the slope of the line. And the slope is the rise over the run. It's the change in y values over the change in x values. So in order to calculate the slope between 2 points A, f of A, and B, f of B, the slope is given by this equation, the quantity of f of B minus f of A divided by the quantity of B minus A, because this is the difference in y values over the difference in x values. And then we can just plug that in and get the formula for the slope of a line, and it'll show up on the graph here. So in this, you can actually click on the second point, b f of b, and move it around and change the secant line. And what I'm going to try and demonstrate for you is as we move the point b to be really close to the point a, we'll get a better and better approximation to the tangent line. So I'm going to zoom in a little bit. So if you just look in this little bit of the curve around here, it almost looks like it's a straight line already. And by moving the second point B in very close, then you can see the blue line gets very close to the curve. So the curve is basically approximated by the line, which is the blue line. And then I can move it even closer. I can zoom in further and further. I can move it slightly closer, but I'm going to soon run out. That's as close as I can get it. But right now, the curve looks like it's almost a perfectly straight line, and the blue line and the curve are almost taking up the exact same space. So this is a program that uses a website, Desmos, that you can check out for yourselves. I've put a link to this very program on the Blackboard site from this course. And what you can do is you can move the A point around, you can move the B point around, and you can get different secant lines. You can even change the function. So for example, maybe I want to look at the function x plus sine of x. Now I can zoom out a little bit, and then we've got the function x plus sine of x, and then I can play around and look at the different secant lines for that and try and approximate the tangents with that secant line. Again, you can find a link to this program on the Blackboard site for this course.